Hello everyone. In this lecture, we will investigate structural models and see how they are used in system modeling. Structural models of software display the organization of a system in terms of the components that make up that system and its relationships. Structural models are the static models, which show the structure of the system design. You create structural models of a system when you are discussing and designing the system architecture. The frequently used structural diagrams are deployment, package, component, and class diagrams. The purpose of the diagram is to allow a designer or technology architect to create or view a model of a virtual or physical deployment environment. The diagram shows the typical website deployment view. Some of the elements we see here are very often present when we create a deployment diagram. The very common element of the deployment diagram is called a node. There are two types of nodes: device nodes and execution environment nodes. Also, one can create an untyped node or assign a custom storage type to a node. A node in particular is a hardware or software object shown by a three-dimensional box. The nodes are connected using a line. Normally, it indicates what kind of communication should be established between nodes. In this example, we see that there is HTTPS communication between Android and LAMP bundle. A LAMP bundle maintains TCP/IP connection with a database server that is running the MySQL database management system on a Linux operating system. Within execution environment nodes, you see the artifacts. The artifacts are shown as green boxes. The artifact may be any element deployed in a system: a file, application, database, and other. The smartphone with an Android operating system should have an installed browser to view a website. There is a PHP script installed in a web server to generate a website. And finally, a database should be populated using a mydb.sql file. In such a way, the deployment diagram describes the physical deployment of the software on hardware components. In this CForce deployment diagram example, you see the deployment diagram of an internet banking system. CForce deployment diagram is not much different than the UML diagram provided in the previous slide. The authors of CForce claim it to be the slightly simplified version of UML's deployment diagram. The diagram is giving more contextual information on system devices, execution environments, and packages by using boundaries. Package diagram. The purpose of the package diagram is to provide a visual representation of the package structure which may not be obvious to people viewing the model without the project browser. The visual containment shows the child packages that are owned and by the parent package and is present by nesting the packages inside each other. It is typically used in the earlier stages of an initiative when it is important to show the contents of packages and the packages of which they are comprised. Class diagrams. Class diagrams are used when developing an object-oriented system model to show the classes in a system and the associations between these classes. The purpose is to allow analysts and other stakeholders to be able to create and view elements that represent important entities in the domain of interest and the structural or semantic way they are related. The relationships are added to show how elements relate to each other and can be adorned with multiplicities and role names to describe these relationships in more detail. It is typically used early in an initiative to describe the important elements in a domain. These diagrams are not only useful for analysis, but also as a fundamental tool for sharing knowledge and ensuring that all stakeholders share a common understanding of the important entities in the domain being discussed and how they are related. The class notation includes three parts: the class name, written in the upper section, attributes provided in a middle section, and methods provided in a bottom section. See the point class example on the right. The class diagram shows the building blocks of any object-oriented system. Class diagrams depict a static view of the model or part of the model describing what attributes and behavior it has rather than detailing the methods for achieving operations. Class diagrams are most useful in illustrating relationships between classes and interfaces. Generalizations, aggregations, and associations are all valuable in reflecting inheritance, composition or usage, and connections respectively. The diagram illustrates aggregation relationship between classes. The lighter aggregation indicates that the class account uses address book, but doesn't necessarily contain an instance of it. The strong composite aggregations by the other connectors indicate ownership or containment of the source classes by the target classes. For example, contact and contact group values will be contained in address book. The key points of this lecture: Structural models depict the elements of a system that are independent of time and that convey the concepts of a system and how they relate to each other. Structural diagrams display the organization of a system in terms of the components that make up that system and its relationships. You create structural models of a system when you are discussing and designing the system architecture. Thank you for watching. Hope to see you in the next lecture.